In the present video, we will discuss the graphical method to solve the two jobs with m number of machines of a sequencing problem. Let's see the problem. Use graphical method to minimize the time needed to process the following jobs on the machines as shown in the below. Also calculate the total time need to complete the both of the jobs. Here given the job 1 and job 2 with the different sequence of machining times. That is, for job 1 sequence is A, B, C, D, E, and for the job 2 sequence is C, A, D, E, B. Let's see the solution. First step is draw horizontal and vertical axis on the graph sheet. Horizontal axis represents the total machining time for job 1 and vertical axis represents the total machining time for the job 2. These are the horizontal and vertical lines which represents the machining time for the job 1 and machining time for the job 2. Next step is mark the machining time for job 1 and job 2 on the horizontal and vertical axis. Here total machining time for the job 1 is 17, that is 2 plus 3 plus 4 plus 6 plus 2. So total machining time is the 17 for the job 1 and total machining time for the job 2, that is 4 plus 5 plus 3 plus 2 plus 6 equal to the 20. So we have to mark the 17 and 20 at the horizontal and vertical axis. So we have to mark the total machining time 17 on the horizontal axis for job 1 and mark the total machining time 20 on the vertical axis. Here let consider 1 centimeter equal to the 1 hour of the machining time. So we have to mark the 17 centimeters is the total machining time for the job 1, which has to represented on the horizontal axis, and 20 centimeters is represented the total machining time of the job 2, which is represented on the vertical axis. Next step is construct the various blocks starting from the origin by pairing the same machine until the end point. First mark the sequence of machines with machining times for job 1 on horizontal axis. Next mark the sequence of machines with machining times for job 2 on the vertical axis. Then pair the same machines for job 1 and job 2. So first you have to mark the sequence of machines for job 1 on the horizontal axis. First machine is machine A and machining time is 2 hours for the job 1. So we have to mark the machine A on the horizontal axis from the 0 to 2 centimeters. So this is representing the machining time for the machine A on the job 1. Next machine is B and machining time is 3 hours. So mark the machine B on horizontal axis after the machine A with the 3 centimeters. So this is the machining time for the machine B on the job 1. Next machine is the C and machining time is 4 hours. So mark the machine C on horizontal axis after the machine B with 4 centimeters. Next machine is D and machining time is 6 hours. So mark the machine D on horizontal axis after the machine C with 6 centimeters. Next machine is E and machining time is 2 hours. So mark the machine E after the machine D with 2 centimeters. Next we have to mark the sequence of machines for job 2 on the vertical axis. Here first machine is C and machining time is 4 hours. So mark the machine C on vertical axis from 0 to 4 centimeters. Next machine is A and machining time is 5 hours. So mark the machine A on vertical axis after the machine C with 5 centimeters. Next machine is D and machining time is 3 hours. So mark the machine D on vertical axis after the machine A with 3 centimeters. Next machine is E and machining time is 2 hours. So mark the machine E on vertical axis after the machine D with 2 centimeters. Next machine is B and machining time is 6 hours. So mark the machine B on vertical axis after the machine E with 6 centimeters. Next to construct the various blocks by pairing the same machines for the job 1 and job 2. For this, first we have to draw the vertical lines for various machines at its respective machining times for the job 1. Similarly, we have to draw the horizontal lines for the various machines at its respective machining times for the job 2. Next we have to shade the common area for the same machine for job 1 and job 2. Let's see for the machine A, which is on the job 1 as well as the job 2. So here this shaded area is represents the machining time for the job 1 and job 2 on the machine A. Similarly, we have to construct the shaded area for the machining time of job 1 and job 2 on the different machines. So this is for the machine B on the job 1 and job 2, and this is for the machine C, and this is represent the machining time for the job 1 and job 2, and this is for the machining time for the job 1 and job 2 on the machine D. This is represent the machining time for the job 1 and job 2 on the machine E. Next step is draw the diagonal line with angle of 45 degrees with the horizontal axis from origin to end point. And moreover, this diagonal line should not cross the blocks, so it moves diagonally, horizontally and vertically. If the diagonal line is in the horizontal position, it represents the job 1 is under process and job 2 is ideal. Similarly, this line is in the vertical position, it represents the job 1 is ideal and job 2 is under process. Moreover, this diagonal line is in the inclined position, it represents the job 1 and job 2 are the under process. Now draw an inclined line which makes the 45 degrees with the horizontal axis, and we have to draw this inclined line up to the coordinate of 9, 9. Furthermore, if we continue this inclined line, it crosses the shaded block. So now we have to draw a vertical line up to the end of this block with 3 cm height. Then continuously this line, inclined line up to the end point. Now we have to calculate the total elapsed time for the job 1. So total elapsed time for the job 1 is the processing time for the job 1 plus ideal time for the job 1. So in the data it is given that one the machining time or processing time for the job 1 is the 17 hours. And ideal time for the job 1 is calculated by this line. And here, if the line is in the vertical position, it represents the ideal time of the job 1. So here it is the 3 centimeters of the height is the vertical line. So 3 hours is the ideal time for the job 1. So total elapsed time for the job 1 is the processing time 17 hours plus length of the vertical line, that is the 3 hours. So 17 plus 3 total is the 20 hours is the total elapsed time for the job. Similarly, we have to calculate the total elapsed time for the job 2. It is the processing time for the job 2 plus ideal time for the job 2. In the data, it is given that total processing time for the job 2 is the 20 hours plus ideal time for the job 2 is the length of the horizontal line. So in the diagram, this line is not having any horizontal line. So length of the horizontal line is the 0. So total elapsed time for the job 2 is the 20 hours. So this is the solution, and thank you.